right, so far with infinite series, we found the sum using partial sums. And if it's a geometric series, we can easily find the sum. And we've also used the nth term test to find if a sum converges or diverges. We're going to be digging into some different tests that we can use when the nth term test is inconclusive, or we just don't want to use the nth term test. So we are going to first of all be looking at the integral test. At the end of this lesson, you'll be able to determine whether an infinite series converges or diverges using the integral test. Right, just one note before we get started on this test. The test is for series with non-negative terms. That means that none of the terms in the series are negative. So if we do have any negatives, the integral test would not work. All right, the integral test, I'm just going to read through a little bit of this. The a sub n is going to be our sequence, and we are going to let actually our sequence be a function where f is continuous and it's decreasing, all right, for some fixed term of n. Then the series and the integral either both converge or diverge. So if we can take the integral of the a sub n, and we'll go from n to infinity. When we do that, if we get an answer, then our sum will converge, and if we don't get an answer, like infinity, then our sum will diverge. All right, biggest thing on this one is our n. We get to actually pick it. We just need to make sure whatever n I pick, the function is decreasing after that number, and I'll give you an example to use that. And then just remember, if I'm going to take the integral from some number to infinity, we do actually, remember, we'll call this a letter instead. Again, I usually like to call it w. We will find the limit as w approaches infinity. So we're not actually finding the integral all the way to infinity. So just be careful on your notation on that one. All right, so as an example, if I had the sequence 1, 1/2, 1/3, 1/4, 1/5, and it kept going, notice the first term, after the first term, everything is decreasing already. So I could use, just starting with the first term, on through. So when I went to do this, I would go for the integral from 1 to infinity. However, if I had 1, 1, 1, 1/2, 1/3, 1/4, and then got going, I would actually pick the third term to start with, because after the third term, the numbers are decreasing. So we just need to be careful when we're picking that number that we pick an appropriate number. So you'll want to, when you do this, you'll probably want to go out a few terms just to make sure that your terms are actually decreasing when you do this. All right, so here is our example. Does the series of n equals 1 to infinity of 1 over 2 n minus 1 converge or diverge? And it says to use the integral test to decide. So we actually are going to take just this part right here. We're going to take the integral. It's going to go to infinity of 1 over 2 n minus 1. And just because this says n equals 1 doesn't mean that we have to use 1. If this does not work, we'll see. The first term, if you plugged in 1 for this problem, we would get 1. And if I plugged in 2, I will get 1/3. And if I plug in 3, I'll get 1/5. So it does look like we can still use 1, because after the first term, we are decreasing. So we will use 1. And now remember, we can't technically do that, so we actually will be finding the limit. We'll call this w, as w approaches infinity, of 1 to w of 1 over 2 n minus 1. And again, that might seem kind of a useless step, but it is important so that whoever is reading your paper realizes that you know you can't actually plug in infinity and get an answer. Alrighty, so from here, if we're going to take the integral of this, I'm going to do a u substitution. So I'm going to let u equal 2n minus 1, which means du would be 2. So I'm missing a 2 on the inside, so I need to put a 1/2 on the outside. So I now have 1/2 the integral of du over u, which is ln. So I'll have 1/2 ln of u. And then I will be evaluating it at 1, w, and 1. So if I plug in w, I'll get 1/2 the natural log of 2w minus 1 minus 1/2 the natural log of, if I plug in 2, I'll plug in 1, excuse me, I'll get 1. The natural log of 1 is 0. And so now this integral, the simplest this integral will go is 1/2 natural log of 2w minus 1. We now get to find the limit of that, don't forget, as w approaches infinity. So now if we plug in infinity for the w, we will get infinity. So since we got infinity, since the integral diverges, so does the series. So now we can say that the sum diverges. And that's pretty much the integral test. You'll definitely want to use this when it looks like it's easy to take the integral of whatever you're doing.